Hi, I'm Robert Johns. I am a technical editor at hacker.io. I have 2 PhDs in engineering and a lot of experience in data analysis, working with data and programming, probably over 15 years of programming, 10 plus years of data analysis for a range of fields and reasons. Well, I think the first thing is you have to understand what a data scientist does to understand why you need to learn. So if you think about it, a lot of people probably assume data science is a really fun, easy to do discipline where you play around with data, generate interesting insights out of the middle of nowhere and generate growth and drive profits, etc., etc. But at the heart of it, it's really a very technical discipline. And the language of data science is really spoken in both math and programming. So if you want to be a data scientist, you cannot escape the need to be good in both math and programming. And if that scares some people off to begin with, it really shouldn't, because the math is very specific and the math is easier to learn, and it's also quite, I'd say, applied math. You're doing something with it. You're not learning the theory for the sake of the theory. You're doing something with math, which is interesting, which is why I think it's actually something that when people start to learn, they find it's quite easy because they're often seeing ways they can apply this math. And I think I would emphasize math over programming more, because I think you have to have the mindset of how to use math, and that is essentially stats, probability, linear algebra, and calculus. If you can combine those skills in creative ways, because it is a creative discipline, you then use programming to actively do something with those skills. So I would say that if someone wanted to learn from absolute scratch, I would hope they understood a little bit of math, because if you didn't have any math, you probably really should take a high school math course or something first, because otherwise you will struggle. It isn't a discipline where you can, I suppose, in essence, just pick it up out of nowhere. Like you genuinely do need to have a basic in maths. You have to understand algebra. You have to understand some simple high school math. But if you have that, I would say stats. Get into stats. Stats are by far and away one of the most important things you will ever use in data science. You use stats all the time for everything. So I think stats is a big area. If I say to someone learn statistics, they'll think, okay, the mean, the mode, the median, yep, that's all super interesting. And you'll use that a lot. But there's a lot more to stats than that. It's its own field. People do PhDs in statistics. It's a very complicated field. So I would say learn a lot of statistics. Think about the basics. You need to learn inferential statistics, descriptive statistics. If I'm talking descriptive, I mean the mean, the median, the mode, standard deviation, terms that most people have heard, even if they don't fully understand how to use. These are things that we use every single day. Doesn't matter what you're doing, you will use these terms, you will use these ideas to look at data and to understand something about it. And then you have inferential statistics, and that is where you're trying to figure something out, you're trying to infer something from data. And this refers to populations and samples. If again you're not familiar with statistics, this might be a bit confusing. I use the word statistics to describe the field, whereas a statistic itself relates to a sample, whereas the population relates to the entire world. And the idea of stats is to try and make inferences about the world from a sample. So you have descriptive statistics and inferential statistics, and both of those basically make up everything you will ever do in data science at the heart of it. And then when you get into that, you want to learn about hypothesis testing and confidence intervals and p-values. And these are all skills that are very concrete. But when you learn them, and you learn them for a reason, and that is to try and figure something out from data to make a decision about the future, it becomes easier to grasp why you're learning these things. If I said to someone, go and learn stats, they'd probably get bored really fast, because I think it's quite a dry subject. But if I gave you a data set that was interesting, said I want to use statistics to analyze this data set, and then to be able to figure something interesting out from this data set, it becomes a more engaging discipline. So I could literally speak for an hour and a half about stats. There is a lot that you could learn. As I say, you've got everything I've mentioned. You've got regression, you've got Bayesian statistics, you've got experimentation, A/B testing, control groups, overfitting, underfitting. All of these areas are parts of stats that you will just naturally layer onto your skill stack as you spend the time learning it. And the reason that you'll learn them will make sense when you're doing something purposeful with it. So don't view stats as something you have to learn just because. Learn it because it will essentially inform all of the actions and all of the things that you do as a data scientist. A data scientist is a statistician. He understands stats, or she understands stats to a level where they can assess data, understand what's going on, and make decisions in a calculated and a quantifiable way, because that is essentially the key. You need to be able to quantify what you're doing and why you're doing it. So stats, learn stats, just cannot stress it any more than that. Just don't be afraid of it, dive into it. And then of course its brother is probability. Don't mix the two up, they are different disciplines. You often hear probability and stats as if they're one and the same. They're not, they're different. Statistics is looking at data and trying to understand what's going on. Probability is a little bit more magical sometimes, I think. Probability is something that we've all heard about if you've ever looked at, I suppose, let's think, gambling. Whenever you see the odds, that's probability. Everyone's familiar with the idea of the odds, the probability, the likelihood of something happening. And probability is something that you will do a lot of as well. Maybe not so much as stats, but you'll definitely be using it in your day-to-day. So you have to understand the basics. You need to understand the idea of what an event is, the difference between an independent and a dependent event. Conditional probability, if something's happened, will that change the probability of something happening in the future? It all ties together. You've also got probability distributions. Many people have heard the phrase a normal distribution, the bell curve, one of the most famous distributions of probability. You've obviously got binomial distributions and Poisson, uniform and exponential, etc. These are all ways that you can assess the shape of data to figure out what to do with it, to figure out what you can and can't do. And it ties very neatly into stats. You put the two together and you will have an arsenal of skills that allows you to approach any data set, to be able to analyze that data set, to be able to figure out what's going on, and also try and figure out how can I do something useful with this? How can I make predictions about the future? How can I make inferences about what may happen based on what I've seen happen? So probability and stats, super duper important. And then you've got the rest of the math, which is linear algebra. And depending on how far you've taken your math career, linear algebra is essentially working with matrices, which are not that scary really. They're just big groups of data and columns and rows. And often in data science, you'll be dealing with matrices and data sets that come in matrices, or you'll be transforming them into matrices. So understanding matrices, vectors, transformations, and decompositions. These are areas where when you get into data science as a data scientist, you will naturally gravitate towards machine learning. Machine learning and data science are joined at the hip nowadays, especially when you move from junior to a standard data scientist. And to be able to use machine learning properly, linear algebra will become non-negotiable. You cannot do machine learning with the knowledge of knowing that what you're doing makes sense unless you understand linear algebra. There's something I should have said at the very beginning, a huge disclaimer. If you want to learn to use data science libraries and tools right away, you can abstract away all of the math, all the stats, all the linear algebra, and all the calculus. You don't need to understand it. I can say, go and do this in scikit-learn, and you'll spit something out and realize, oh, that was easy. I'm now a data scientist. The challenge is, how can you tell whether what you've done is correct? How can you tell whether what you've done is substantiable? And you can't do that unless you understand the foundations of what I'm discussing. So it might sound like it's easy to get into it, because it is. I could show you an hour course on becoming a data scientist and you'd be an expert in scikit-learn. If someone asks you to explain why you've used that model and what the limitations are of that model, without these math skills, you'll struggle to do so. And that would never happen in the real world. You can never get a job as a data scientist by saying, I'll learn scikit-learn in an hour. You've got to be able to prove that you understand what scikit-learn and other models and libraries are doing. So linear algebra, really important, as is calculus. And I think calculus is one of those things that a lot of people find sometimes intimidating, depending on your math background. There's lots of things going on, whether you're talking about integration, differentiation, differential calculus, differential equations. You don't have to be an expert in these areas, but you have to have an appreciation of what it means so that you can assess models and assess techniques that you will use as to whether or not they're appropriate for what you want to do. And so much of the math that you learn isn't about being an expert in math. It's about being able to understand what your techniques are doing, why they're appropriate and why they are inappropriate. And if you can understand the math behind them, you can make those decisions. So math, far and away, is essential to becoming a data scientist. There is no escaping it. It is probably the one thing that I would say would maybe put a lot of people off in a way, but I don't think it should, because once you cross that bridge and you start to learn and you start to do something with it in a practical way, you'll see that it's actually all relatively straightforward. It looks scary from the outside because it's always presented in a dry and theoretical way. Data science isn't dry and theoretical, it's hands-on. It's here's data, tell me something interesting. So having that to play with makes, in my opinion, math way more interesting than it ever was at high school.
I think you've nailed that first section. If we titled that first response, that first response would be, do I need math for data science?
Yes.
And the answer is yes. You do.
Absolutely.
Which is great. And I like that you've broken down, stats is different than probability, and here are the different areas within stats and different areas within probability that you're going to need to be familiar with. I'm glad that you broke out. You will also need linear algebra, because I keep hearing this is going to be a fundamental if you want to take a course at Stanford, for example, on AI. Linear algebra is always listed as vital, and you're saying it's vital specifically for machine learning. If you want to move from junior to senior, this is something you'll need. The last thing I heard that was really valuable was that calculus is the other, like the number 4 area within math you need to make sure you're familiar with. I'm going to ask you another general question next, but before I get to that, if you wanted to learn, maybe you wanted to refresh your knowledge, you've already taken calculus, maybe this has been 10, 20 years since you've been in a classroom, where would you brush up on stats, probability, linear algebra, and calculus? In
terms of where you would go to learn, specifically?
What are your favorite resources online? Okay. I'm familiar with Khan Academy, but I'd like to
hear you say it. Absolutely. I genuinely would. For any age group, Khan Academy, you literally cannot go wrong. He covers everything that you need. If you wanted to learn the math for data science, he has all of the modules, he has it all broken down. There are videos, there are exercises, there are quizzes, and there are very few people I've found that make it as easy to understand as he does. I could take one of those classes during a PhD with no shame, because I understand that what I'm learning is actually important. I don't care whether it's in a textbook or it's by somebody with all of the credentials in the world. He does it well, and he does it right. There are no errors. So if you want to learn any of this stuff, go there, because you'll have fun. And that's what I like about it. He makes it fun. He makes it relatable. And that is, I think, the key to learning math for something like data science. Don't make it boring, whatever you do. Don't buy a textbook with all of these chapters in and think you're going to do it on your own, because you're going to get bored within a day. Trust me. It's unless you are a true math head, which there are very few people who are like that. I think you need something like Sal Khan at your side, because he's always having a good time, and you feel like you're having a good time learning with him. So yeah, he has my vote without a doubt.
Perfect. Okay, so you've got the math background. You are a math expert. You know stats, probability, linear algebra, and calculus inside and out. Now you want to get a job in data science today. It's 2024, it's 2025. You're ready to get a job in the field. What must you know? And in what order must you learn it?
Okay, so if you have all of those skills, you have to know how to program. You cannot get a job as a data scientist if you are not a programmer, because everything you do in data science involves programming. It's as simple as that. And ultimately, you are probably going to choose between Python or R. I think a lot of people from academic backgrounds would favor R, and I think R is a perfectly good language. I would favor Python, because I think it has a community that is perhaps a little bit more accessible for people who are outside of academia. I think the documentation is better as well for people outside of academia. I think you need to learn to program. You need to know the basics. If you don't have the basics, and that is obvious things like you need to know the syntax, data types, operators, variables, iteration, conditionals. These are all things that are just givens. You need to know how to program. It's not about I can build apps. It's about you understand the concept of programming so that you can apply it to a data science field. When you have programming and you have Python, for instance, you need to know some specifics, and the specifics are really going to be related probably to libraries. A lot of data science, and Python in particular, revolves around using certain libraries. So whilst you need to understand file input and output, which is just a Python basic, you need to know what to do with that file once you've input it, and that's probably going to mean learning how to use pandas. Now, pandas is incredible. It's absolutely incredible. It's one of the best libraries ever created, in my opinion. For data scientists, they would not be able to work, I think, today without pandas. It is as easy as breathing. If you think Python, you think pandas. You're using it all the time. And pandas does a lot. You can import data from various formats, CSVs, JSONs, databases, whatever you like. But you were using it for some of the most essential roles as a data scientist. As a data scientist, especially if you're coming in at the start, a lot of what you're going to be doing is less building incredible predictive models and more figuring out and cleaning data. Data cleaning is one of the most important roles of a data scientist. You usually get unstructured data or messy data or incomplete data, and it will be large. It won't be a spreadsheet with 100 rows in. We're talking giant data sets with lots of issues. And you're going to be using Panda to handle missing data, drop duplicates, replace values. You're then going to be using pandas to do exploratory data analysis, which is one of the key elements as well, and that's using your statistics. You're going to be looking at summary statistics. You're going to be doing some manipulation. You're going to be adding columns, dropping columns, renaming columns, sorting and filtering data, doing things that you're probably familiar with in Excel, but you'll be doing them with far larger data sets in a more powerful and quick and efficient way in pandas via Python. The list really can go on with pandas. You can do it for data transformation, merging, joining, handling time series data. Time series data is one of those areas of data science which is very common. Time series data is just data that's been gathered over time, so you're looking for time-based trends. Pandas also excels when you're working with any type of data, so whether it's structured or semi-structured or unstructured. It's a very easy to learn library. It's essentially, it's its own skill within Python. It's got its own syntax, as you would expect, but it's a very easy to learn skill, and when you learn it, the power of it is undeniable. And when you're using pandas day to day, you'll find that anytime you have data to work with, you'll immediately be importing it into pandas. You'll never think about doing anything else with it. So as a junior data scientist in particular, a large part of your role will probably be handling data, sorting out data, making it clean, handling any errors with it, making it usable so then it can be analyzed. And that might be yourself, that might be someone that's higher up the chain, depending on the size of your team. But pandas and Python are things you have to know. You've got all your math, all your stats, all your algebra, etc., and you'll then find yourself using none of it to begin with because you'll be working with pandas to just clean data. That's fine. But once you get past that, you'll then be using something like NumPy. And NumPy is actually closely related to pandas because pandas is built on top of NumPy. And NumPy is what you use for essentially numerical computations. Now, when I say numerical, I'm talking about maths and stats. This is where you start to do this. You're using NumPy to work on the data. You may have reorganize the data using pandas, then you could be using NumPy to operate on it. And you can also do things like element-wise operations on giant arrays, which you cannot do with Python lists, which is why NumPy is so helpful as well. Linear algebra operations, perfectly doable. Everything in NumPy is an array, which is why linear algebra is so important. And the reason that we use arrays is because they are so efficient in NumPy. So efficiency is a big thing when you're working with big data sets. The larger your data set, the longer it takes to do things on it. And if efficiency comes into play, NumPy is where you want it to go. It also offers something called vectorization, which is a method where you can essentially remove the concept of iteration altogether. People are used to for loops to go iterate over a list and do all of these things. With vectorization, you can take that out of the equation with NumPy, work on gigantic arrays of data, and flatten your time by factors of like 1,000. And that type of efficiency gain is enormous when you're trying to do things quickly. And in data science, like most disciplines, you have the time to play, but you also have results to produce. So the faster you can do things, the more efficiently you can do things, the more often you can iterate over ideas. That's why you would use a tool like NumPy. So NumPy and pandas together, utterly essential. Pandas sort out your data. NumPy, linear algebra, calculus time, work on your data. So your skills start to come into play. But you know, they're not the only things that we use. There are other skills you need to use in Python. For instance, web scraping is something you may be doing, and it links back to data. Collecting data is something you may have to do as well. Data isn't always handed to you. Sometimes you have to go and find it yourself. So one approach is to scrape the web, and you can use Beautiful Soup or ScrapeEye or Selenium. These are all great tools. These are also all libraries you can use with Python. Similarly, APIs. Everybody knows about APIs. RESTful APIs are absolutely everywhere. And oftentimes there are some excellent APIs you can use to scrape an enormous amount of data from a public repository, and then you can use that, import it into your own repository, and then start working on pandas and start doing everything. So data, everything you're doing is linked to data, whether you're collecting data, cleaning data, or analyzing data. You'll be doing all of this with Python, and you'll be doing all of it predominantly with a small number of libraries. Pandas and NumPy, again. You'll use those probably more than anything else. But the next part is that you also need to know how to do data visualization, because the one thing about being a data scientist is that you are supposed to have the expertise and the technical knowledge to take a data set, analyze that data set, extract hidden insights that other people would never have been able to find. But oftentimes these are hard to understand, and you need to communicate it to non-technical stakeholders who do not care that you use pandas, who do not care that you use this particular probability distribution, who do not care about your hyperparameters. They do not care. They want to see a chart that is easy to read, that tells them if I do this, my profit is going to there. Or if I do that, my inefficiency is going down to there, etc. So a data scientist is not only a technical person, he is or she is a storyteller. Your whole purpose is to tell a story from the data. And data visualization is the way you do this, because everybody can understand an infographic or a chart if it's well designed. And once again, Python libraries are there to help you. Whether you're using matplotlib or Seaborn or Plotly, any of these are perfectly fine. They all tend to integrate very nicely with these other libraries of pandas and NumPy. And you can generate very quick visualizations for yourself, or very pretty visualizations for presentations for higher ups or non-technical stakeholders, etc. But telling stories with data via data visualization is probably the one part that a lot of people don't necessarily think about. But data science is a business-facing activity. The whole point is that it does something for a business. It isn't just to find interesting things, unless you're doing a PhD, which is fine. You're doing something interesting because there's an economic implication which is good for the organization that's asked for that to be done. And the best way to communicate that is with visualizations. And one of the best things about visualizations is that you can get better at those by doing it for yourself. And the reason I say that is that when you start with data, one of the easiest ways to figure out what's going on is to create a chart, is to create a plot before you dive in and start looking at stats and everything else. You create visualizations to try and see what's the trend, what's happening here, how is data clustered, what's going on. Maybe if I do this regression analysis, I can figure out some coefficients that I just can't see in the data by looking at it manually. Visualizations allow you to do this, and it gets you better practice at using these libraries. It makes you understand the power of them yourself, which further reinforces the power of why they're useful for other people. And it just ties into this whole sphere of data. You've got data to play with, stories to tell, and ways in which to present it. And it all rotates, it tends to rotate around 3 or 4 libraries: pandas, NumPy, and matplotlib. You'll just be there and there again and again and again and again and again. And if you want to get a job as a data scientist, you want to land your first role, you're hard pushed to do so by only knowing maths and stats. You need to be having some practical skills in these areas. And I would say that, much like learning maths and stats, don't do it for the sake of it. Do it in a way that makes sense. With these skills, one of the very best ways, undeniably, to learn these is to do it practically. And that means taking on a project. And that means taking on a real project if you can. And I would recommend, undoubtedly, to go to Kaggle. Now, I don't know if you're familiar with Kaggle, but Kaggle is I would call it a data science website, on the most part, where they have a community of data scientists, machine learning engineers, and other people that come together, sometimes for competitions or something just for educational purposes, to work on real large data sets. There are loads and loads and loads of projects that you can use to learn how to do something with data science in a practical way. You can get a real data set, whether it's something famous like the Boston housing data set. You can download this and there'll be some requirements to do something with it, and then you can look at how you've done it and compare it to other people's solutions. And you can use this information to do something that's not only going to give you a real world taste of what data looks like, a real world taste of how stats applies to real data, but you'll also be able to network with other people who might be learning, or who even maybe have jobs and they're looking for new people to hire. Or you can take part in competitions, which are tremendous, because if you can do something really cool in the competition, you can stand out. So it's a great way to boost your portfolio and to boost your presence in the field. So learn all this stuff, but do it with something that's meaningful, so that when you're in an interview, you can talk about something meaningful. You can say something that actually matters. You can say, hey, I understood that when I had this data, there were all of these issues with it being a mess, and I had to figure out all this stuff. And then when I made visualizations, I forgot that there was this trend that was going on. So I was able to figure that out and then decide what method or analytical technique to employ to make a prediction. And when you talk about it in these ways, you're showing that you've done something meaningful. You don't know a lot. If you're new to the field, don't try to pretend that you do. It's absolutely fine to know not a lot, but it's great to show that you've been willing to get stuck into something that's realistic, rather than I've learned how to use pandas and I understand how to use a drop NA method to drop all the NaN values. Like, can I have a job? No, because that's simple. I want to see that you will do something practical with it. And I think projects, wherever you find them, and Kaggle is a great resource, is the best way to practically apply everything. All your maths, all your stats, all your linear algebra, all your calculus, all of your Python skills, and all of these libraries in a way where at the end, sometimes it boils down to one chart or one table, and you've done all of this to get there. But that's fine, because you've taken the journey of a data scientist, because every day as a data scientist, often it takes longer than one day to complete a project, but you're putting all these skills together to generate a single output. And doing that for yourself will put you in great stead to try and get into the field, because then you'll feel like, okay, not only do I understand what they do, I think I like it, I'd like to do more of it, and I can talk about it with some more confidence in an interview.